Okay, so we're doing lesson 23 today, right? Graphing trigonometric functions. So we're going to talk about the graphs really. And the functions, we can talk a little bit about the functions as well. We talked about the unit circle, and you can think about the unit circle as, several points. Of course, remember they come from radius 1, right? A circle of radius 1. If you look at particular angles like 60 degrees here, you can find a certain x value and a y value. And those x and y values, of course, would be your sine or your cosine and your sine values. Okay, but if you think about it, the circle that you get from those points would be an output of sorts, right? Where all the angles are inputs. And if you take the x's and the y values, those points generate a circle, which would be the output, okay? Well, if we look at the individual components, right, like the x's, you plug in theta for your input, your angle, and you get an x value. Well, this will give you your own function here. We'll typically write it out like y equals cosine of x. Okay, same is true for sine. Okay, and so notice the variables are kind of changing a little bit. That's okay. Remember, this x is going to be the input, so that's your angle, and the output says y. Well, we're going to transfer this from a circle, unit circle, to an actual XY plane type graph. Okay. And so you'll see that because you're going around in a circle, right? Like the Y value here is the same thing as at pi over 6 is the same thing as the Y value when you go all the way around and you're at, what would that be? 13 pi over 6, right? So notice it's periodic in that sense. You are going around in circles. There are certain inputs that if you plug them in, you get the same output over and over and over again. And it goes on indefinitely, depending on how many rotations you go on the circle. Okay, and so just keeping that in mind, let's talk about these individual functions. So here is sine, okay, y equals sine of x. And you'll notice, let's kind of look at it a little bit, maybe do this in a different color here. Whenever x is 0, the input is 0, that's the angle. You think back to the circle, the y value at that point would be 0, right? And so you see it here, the y value is 0. When you get to pi over 2 or 90 degrees, you have 0, 1. Well, that's what this point right here is. That's pi over 2. That's reached a height of 1. When you get to pi, your y value is 0. Well, that's what this is. At 3 pi over 2, your y value is -1. And then so on, right? You repeat the process. Here's 2 pi, here's 3 pi, and so on, right? And you can go in reverse as well. Negative pi, and so on, -2 pi, and so on. Okay, and so this is the graph. It's a wave. It's periodic in the sense that you can see, right? It repeats itself over and over again. You can really see what is called the period from here to here, right? Where it completes one cycle. Okay, and then it repeats that same thing again. Right, so that's what we mean by period. It does the same thing over and over again. Okay, and so how do you identify the period? Well, sine and cosine have the same period, 2 pi. The amplitude is the height. Okay, so how tall does the wave get, if you think about it like that? And the wave will go from here to 1, right? It's 1 unit high, so that's why the amplitude is 1. Okay, of course, you're not counting from the lowest point to the highest point. That would not be, that'd be 2, right? That's not the amplitude. Just like if you're trying to describe how tall a wave was, you wouldn't count from where the wave went down to where the wave went up. You would count from, shoreline to how high the wave went. Okay, the domain will go on forever because remember, you can plug in any angles you want from negative infinity to positive infinity. The range, though, you might notice is stuck, right? It's stuck between -1 and +1. Okay, the range is bounded between -1 and +1. That's what this is saying here. Okay, the roots, right, or the zeros of the function, that'd be everywhere the graph hits 0. So you might see it -3 pi, -2 pi, -pi, 0, pi, 2 pi, 3 pi, and so on. That's why this pi k is here. And I'm not going to say this very often, but when I say k, I am referring to any integer, right? So any number, k is +1, -1, 0, +2, -2, +3, -3, and so on. Okay, so that's what k represents. And so you can think about this as 0 pi. That could be 1 pi. That can be 2 pi. It could be -1 pi, be -2 pi, right? So that's what this notation just means. Okay. Cosine will look very similar to sine. The only real difference here is that instead of starting at 0, right? Sine starts at 0 and then goes up and then down, right? That's what sine does. Cosine starts at 1, and that makes sense if you think about the circle, right? If you're starting at angle 0, 1, 0. So sine would be 0, cosine is 1. So that's what you see here. Okay, cosine is 1. And then the same thing happens, right? Here's pi over 2. Here's pi. Here's 3 pi over 2. Here's 2 pi. And then, of course, you can go in reverse, -pi over 2, and so on. Okay, and so keeping that in mind, you'll see the graph looks very, very similar. The domain, just like before, goes forever to the left and forever to the right. There's no issues with what angles you plug in. But again, the range is bounded, right? It's stuck between +1 and -1. Okay, the roots or the zeros occur here, right? And you'll notice that's pi over 2, 3 pi over 2. This would be 5 pi over 2. This would be 7 pi over 2, -pi over 2, -3 pi over 2. All right, so it's like the odd numbers pi over 2, right? Odd numbers pi over 2. And you'll see that this is represented here. Okay, that notation we'll talk a little bit more about later. Okay. The amplitude, again, is 1. The amplitude is going to be 1 all the time because if you look at the circle here, the radius is 1, right? So the furthest to the right it can go, cosine is 1. The furthest to the left it can go is -1. Okay, so that's the amplitude. And then finally, the period. It starts at 1, goes down, and then up, back up to 1. There's 1 period. Okay, so that's cosine. Here we have some standard form, right? Some kind of generic sines and cosines here. And so if you're trying to figure out the amplitude, vertical shift, all the different types of transformations, these are some keys to look for. Okay, so the amplitude is the height. It's the absolute value of the number in front of cosine. Okay, so you can have something greater than 1 or smaller than 1 if you multiply something on the outside. Vertical shift is just like when we deal with transformations of functions, you add something to the end of it. That'll move it up or down. Okay, the period, if you're trying to figure out when does the wave start over, you do 2 pi divided by b, okay? And b in this case is the number in front of x, okay, for both sine and cosine. It's the number in front of the x. And then finally, the phase shift. When you think of phase shift, think horizontal shift. Each point moves over by a factor of whatever this is, right? So -c over b. So negative whatever this number is divided by that number. That'll move it over to the right or to the left. Okay, let's do some problems here. Here we want to find the phase shift, the period, and the amplitude of the function. I like to do amplitude first because it's pretty easy. The amplitude is going to be 3. Maybe I should fill that in. A is 3. B is the number in front of x, 2. C is what comes after x, which would be negative pi. D is 0 because still have nothing added on the end here. Okay, and so that's my amplitude. Where would I put that? Let's see. The period would be 2 pi divided by b. B is 2, right? So the period is just pi. Okay, so think about what that means, right? If your graph does this, well, now we made it shorter, so it's going to do this. Right? It's just going to start over a lot faster. Okay, and the phase shift is negative c over b. B is 2. So positive pi over 2. Okay, and let's do this one as well. Okay, A in this case is 3. It's a number attached to cosine. B is 5. C is pi over 2. And this one actually has this vertical shift thing, right? This positive 2 here. Okay, so the amplitude is 3. The period, 2 pi divided by b, so 2 pi over 5. The phase shift, negative c over b. Okay, well, when you divide a fraction by a whole number or an integer, you just multiply the two denominators. So that would be 10, negative pi over 10. And this one has a vertical shift, so we'll write that one down as well, which would be 2, a positive 2. We shifted the graph up 2. Okay, so it's just plugging these numbers into formulas. They're really not that difficult to do. Okay, so let's talk about tangent really quick. We don't have to spend a lot of time talking about tangent. But that graph looks different, right? It is periodic in the sense that it does repeat the same thing over and over again, right? Indefinitely. It does, you can see that the period, right, is that. There are vertical asymptotes. And it makes sense because tangent, remember, tangent is the same thing as sine divided by cosine. So anything that would make cosine equal 0 would be a vertical asymptote. And so that would be like right here at pi over 2. Or at 3 pi over 2. Or at negative pi over 2. And so on. Okay, so the vertical asymptotes exist wherever cosine is 0. Okay, the domain would be all the numbers except for where cosine equals 0, where those vertical asymptotes are. So that's what this means. The range is negative infinity to positive infinity. You can see that here. It goes down forever and up forever. And the period is pi, not 2 pi like on sine and cosine. It's just pi. So, and you can think about it from here. The distance from here to here is pi units long. So that's the period. Okay, so let's do an example. Well, maybe not. Here's not example. So that, what does that mean for the period of this function? If you're trying to figure out the generic one, instead of doing 2 pi divided by b, 2 pi divided by b, you divide pi by b. Okay, so what is this going to be? A is 2, B is 1/4, C is 0, right? There's nothing added after the x. D is -3. So my amplitude, A, is 2. The period is pi divided by B. That's pi times 4/1, which is just 4 pi. The phase shift is -c/b. Well, 0 divided by a number is going to be 0. And the vertical shift is -3. Plug and chug, right? All right, the last problem we got to go over is to actually sketch the graph here. And here, I'm going to go over a process that we can use that'll let you sketch the graph. It works pretty much no matter how ugly the function is, okay? So here we have, it says y equals 3 cosine of 2x minus pi. Right here is the graph of y equals cosine x. And I labeled some crucial points here that occur throughout the first period. And you see I listed them here. Okay. So what I'm going to do is figure out the new points. Okay, so these are the old points. We want the new ones. Okay, and so there's a couple ways to think about this. I like to use a little formula. Okay, so I want you to think about this as in here is where you used to have x. I'll put a little 1 right here to represent this is the first x. But then what happened is that you worked it out, or you got this new formula that has inside of it a new x. So if I actually just set up an equation with what I just wrote down, x1 equals 2x2 minus pi, I can actually just solve for x2 and get a formula for x2. So to get x2 by itself, I would add pi to both sides. And then I'd divide both sides by 2. That's a formula to let me transform all my x values on my old function to the new x values. Okay, so let's put this to use. So x2 is equal to x1 plus pi over 2. Okay, well, on the first one here, we're transforming this x of 0, x being 0. So 0 plus pi divided by 2 would be pi over 2. I'll leave the y values alone for now. Okay, if I started off with pi over 2, right, transforming this one now, that will leave me with, okay, well, this is 2 pi over 2, right? Pi is 2 pi over 2. So that leaves me with 3 pi over 2 over 2. And we talked about it earlier. If you have a fraction over a whole number, just multiply the two denominators together. 3 pi over 4. Let's transform the next one, pi. That's going to be 2 pi over 2, which is just pi. So that one actually didn't transform it at all. So that's going to be an x value point that's going to stay in the same position. Okay, x2 for 3 pi over 2 plus pi over 2. That's right, this says 2 pi over 2. So I can have 5 pi over 2 over 2, 5 pi over 4. And then finally, 2 pi plus pi over 2 would give me 3 pi over 2. Okay, so that worked and gave me all my x values. And I'm going to plot all those points in a moment. To find the y values is easier. Just go back to the function here and realize what it's saying here. Here is going to be my new y. It's going to come from, just ignore the trig part. Ignore the trig part and treat that as your old y. So you end up with a formula. Y2 is equal to 3 times y1. Y2 is equal to 3 times y1. All right, and so that's really easy to do. I don't even have to write that out. You're multiplying the old y values by 3. So 1 times 3 is 3. 0 times 3 is 0. Negative 1 times 3 is negative 3. 0 times 3 is 0. 1 times 3 is 3. And there's all my points. Okay, so now I'm just going to plot those points. So pi over 2 comma 3. So here's pi over 2, 3. 3 pi over 4, 0. I'll put these little hash marks here. So 3 pi over 4, 0. Pi negative 3. Pi negative 3. 5 pi over 4, 0. 3 pi over 2, 3. You have a much steeper graph, right? And so it's going to repeat. All right, and you can kind of just sketch the graph, what it looks like, so on. Right, something like that. Okay, and so the point is we graphed the points we needed. Okay, let me go ahead and stop the recording.